So let's try another curved mirror calculation, except this time we're going to have a convex mirror. So a convex surveillance mirror in a convenience store has a focal length of 0.4 meters. A customer who is 170 centimeters tall is standing 4.5 meters in front of the mirror. Calculate the image distance and calculate the image height. So once again, I'm going to use the grasp method. Okay. And I'm going to start off with G, which is all the given information. So here they give us the focal length again at 0.40 meters. However, okay, it is a convex mirror. Convex mirrors have negative focal lengths. Okay, that's important to remember. And here we have person standing 4.5 meters in front of the mirror. That's object distance, so 4.5 meters. Don't worry, I didn't forget about the height. Okay. Height of the object is 170 centimeters. But notice that we have meters for our focal length, meters for our object distance, centimeters for our height. We want all the units to be the same, so we're going to convert this into meters. Okay? And we know that 100 centimeters is 1 meter, so we're actually just going to move the decimal place to the left 2 places, and that becomes 1.7 meters. Okay? So we're going to go straight to what is required. Well, what's required is the image distance, which is di. What else is required? The image height, which is hi. Okay. In terms of our analysis, okay, we're going to use our equations. What are the equations we're going to use? We're going to use the curved mirror equation, which is 1 over di plus 1 over do equals 1 over f. That will help us figure out di. Okay, remember from before, 1 over di actually equals 1 over f minus 1 over do. And here, remember, magnification equals negative di over do, but it also equals hi over ho. And we're going to use that to solve for what hi equals. So I'm going to move on. I'm going to extend my page. And I'm going to move on. Don't need that. Move on, and I'm going to actually do my solution where I'm going to actually plug in my values. So 1 over di equals 1 over negative 0.40 minus 1 over 4.5. I know for some of you it'll be very difficult to deal with fractions and decimals at the same time, but it's okay. The way we handle addition and subtraction of fractions is simply by finding a common denominator. The way you can find a common denominator is always just by multiplying the two denominators together. Okay? And if I multiply 0.4 by 4.5, I will get a common denominator, and it will be 1.8. Okay? Now, if I multiply 0.4 to get 1.8, I had to multiply it by the 4.5. So that's what I'm going to multiply the top number by. So 1 times 4.5 is negative 4.5. Now, I made this top number negative because my denominator now is positive, but here with negative. So I've just transferred that negative up to this 1. So when I multiply the 1 by the 4.5, I get negative 4.5. I had to multiply 4.5 by 0.4 to get to 1.8. So I'm going to multiply the numerator here, which is 1, also by 0.4. So I get 0.4. So from here, I get negative 4.5 minus 0.4. So which is negative 4.9 divided by 1.8. That is 1 over di. But remember, I don't want 1 over di, I want di. So I'm going to flip both of those, and I get 1.8 negative over 4.9. So notice I just put the negative onto the top number. Okay. And if you divide that and actually get a fraction, it becomes negative 0.367 meters. Okay, because everything's in meters. Okay. I'm going to take these guys and move them over just a little bit. Okay. And I'm going to do my solution for part 2. Okay, so the image distance is negative 0.367 meters. The negative means it's behind the mirror. Okay, a negative distance is behind the mirror. So for my solution for part 2, or B, calculate the image height, I'm going to plug in what I know into the equation here. I know what di is. It's negative 0.367, but it's already negative di, so negative di, and I'm going to plug in what I know. Do was 4.5. Hi I don't know, but ho I know is 1.7. So again, hi just equals so the negative 0.367, when you have two negatives beside each other, it becomes a positive. Okay? And when you divide it, I'm going to multiply both sides here by 1.7. Okay? And that's what hi is going to be. This is going to cancel out, and hi is going to equal 0.1386. 0.1386 meters, which we can then round to 2 decimal places, and it'll just be 0.14 meters. Okay? So I'm going to paraphrase now. And I'm going to say, therefore, the height of the image is 0.14 meters and is located 0.367 meters behind the mirror. So remember, before we had a negative height, and that just meant it was upside down. We now have a positive height, which means it's upright. But we have a negative distance, and the negative distance means it is behind the mirror.